We can use Venn diagrams to show the sample space for a scenario. This can help us work out the possibilities of the different events relating to that scenario. Let's look at this example. This Venn diagram represents a group of people and shows the sports that they play. So there are 16 people in total, and 4 of those people play soccer, and 12 of those people play hurling. There's no overlap between the two sets, so there's no one who plays soccer and hurling. Based on this diagram, we can work out some probabilities. So if I pick a person at random from this group, what is the probability that I pick a soccer player? Well, the probability of a soccer player is the total number of soccer players, 4, divided by the total number of people in the group, which is 16, which can be simplified to a quarter. What's the probability of getting a hurling player? Well, there's 12 hurling players out of a total of 16, so there's a 3/4 chance of picking a hurling player. If I pick a person at random, what's the probability of picking someone who plays both sports? We can see from the diagram that there's no one in this group who plays both of these sports. So that's 0 out of 16, which is 0. So the probability of picking someone who plays soccer and hurling is 0. What's the probability of picking someone who plays soccer or hurling? Well, we have 4 people who play soccer, 12 who play hurling, so that's 16 out of a total of 16, which is 1. So the probability of picking a soccer player or a hurler is 1, so it's a certainty. We can write in the probabilities into the regions of the Venn diagram. So this probability here we found out was a quarter, and this probability here, the probability of being a hurler only, is 3/4. So we can write those in, and we can see that if we add up a quarter and 3/4 we get 1. The probability of somebody playing neither sports, well, it's 0. There's no one in this group who plays neither of the sports. So if we add up all these probabilities, a quarter, 3/4 and 0, it adds up to 1. Let's look at another example. This Venn diagram represents a group of people and whether they like Indian food, Thai food, or neither. You can see in this case that the set of people who like Indian food is overlapping with the set of people who like Thai food. We also have some people who don't like Indian food, nor do they like Thai food. So let's look at some probabilities. First of all, what's the probability that someone likes Indian food? Well, the probability someone likes Indian food is 2 plus 3 divided by the total number of people, which is 15. 2 plus 3 is 5 over 15. 5 over 15 is a third, 1 over 3. So 1 in 3 people from this group likes Indian food. So if I select someone at random, I've got a 1/3 probability that they will like Indian food. What's the probability of picking someone who likes Thai food? Well, that's 3 plus 4 divided by 15, which is 7 over 15. And we can't simplify that any further. What's the probability that someone likes neither of these? Well, there are 6 people who like neither Indian food nor Thai food. So that's 6 out of a total of 15 people. We can simplify that to be 2 over 5. What's the probability, if we pick someone at random, that they like Indian food and Thai food? Well, from the diagram we can see it overlaps here, so there are 3 people who like Indian food and Thai food. That's 3 out of 15, which is 1 over 5. Finally, what about the probability of someone who likes Indian food or Thai food? 2 plus 3 plus 4 divided by 15, so that's 9 out of 15, which is 3 over 5. So the probability of someone liking Indian or Thai food is 3 over 5. We can write these probabilities into the Venn diagram. So for this region, the probability is 2 over 15, 3 over 15, and we can simplify that. 3 over 15 is 1 over 5. Here we have 4 over 15. Here we have 6 over 15, which is 2 over 5. If we added all these up, we would get 1. We could also express these probabilities in decimal form. So 2 over 5 is 0.4. 2 over 15 is 0.13 recurring, so we'll round it to 0.13. 1/5 is 0.2. 4/15 is 0.26 recurring, so we'll round it to 0.27. And again, if you add these up, you'll see that they add up to 1. Let's look at another example. This Venn diagram shows, for a group of people, what are the probabilities of having a laptop or a smartphone. And we can see that there's overlap between the two, and that some people have neither. Let's use this Venn diagram to answer a few questions about probability. So if I pick someone at random from this group, what's the probability that they will have a laptop? Well, it's 0.10 and 0.25. So we just add them up. So that's equal to 0.35. What's the probability of having a smartphone? Well, it's 0.25 plus 0.50. That's 0.75. What's the probability of having neither? Well, that's this probability here. So it's 0.15. What's the probability of having both a laptop and a smartphone? That's this region here, so the probability is 0.25. So the probability of having both is 0.25. And finally, what's the probability of having either? So that's the same as saying, what's the probability of having a laptop or a smartphone? So we just add up the probabilities for these three regions. So it's 0.10 plus 0.25 plus 0.50, and that adds up to 0.85. Again, if we add up all the probabilities for all of the regions in this Venn diagram, they add up to 1. That's because no matter who we pick from this group, it's a certainty that they either have a smartphone only, a smartphone and a laptop only, or they have neither. So they must fall into one of those categories. So that's a certainty, so it's a probability of 1. So that's how we use Venn diagrams in probability. Thanks for watching. Talk to you in the next lesson.